All right, Brandon Clayton here, the Algebra Guy. Today, our discussion will cover ratios and how to find unit rate. So you see this bottle on your screen. It's 24 bottles in the pack that cost $3.99. How much is each bottle? How do we figure that out? What is it meant by unit price? So those are some of the questions we're going to answer today. What is a rate and ratio? How are they alike? How are they different? How do we write a ratio and rate as a fraction? What is a unit rate and how do we find it? How do we handle ratios and rates in word problems? I want to cover all that in our lesson today, so stay tuned. First of all, let's talk about a ratio. A ratio compares two numbers or two quantities that are measured in the same unit. Now that's important because the same unit part, because as we get to rates, you'll see something a little bit different. The ratio of A to B is written, you can write it like this, A to B, A to B, A over B, or A to B like this. All of it's the same thing. We're just talking about the relationship between two quantities, and that's how we can represent them. In this section, of all the ways I just circled here on the this A to B part, we're going to focus on fraction notation. When a ratio is written as a fraction form, the fraction should be simplified. If it is an improper fraction, we do not change it to a mixed number. We're just going to leave it the way it is because a ratio is comparing two quantities. So we're not trying to get a decimal answer or change it back to a mixed number. We will leave the ratio, if it was 4, we'll leave it just 4 over 1 because we want to know that it's 4 for every 1 instead of just simply writing 4. Although they equal the same thing in value, this helps us to understand the ratio so that we can see the ratio of both parts. So let's try this one. Write each ratio as a fraction. So these are ratios. Let's write as a fraction. Should be easy, right? 15 over 27. Bam, done. Right? Well, almost done because remember we said we wanted it simplified. So I noticed that there are some common factors in here. Let's pull them out so we can see. So we got 3 times 5. And we got 3 times 9. I'm just going to make that, I'll just do it 3 times 9. And by doing that, I can see that my 3's are going to cancel out, leaving with 5 over 9. And so there is my fraction as a ratio for A. For B, we got 45 to 18. And please leave it in the order that they give it to you. Notice I put the first one in the numerator and the last one in the denominator. That becomes important if they are asking for the ratio between dollars and the dollars from this person and the money from that person. But if you change the order, we're going to forget which person you're talking about. So we're going to keep that same order. Then we're going to make sure this is simplified as well. I noticed that 18 and 45 both have a 9. Yep, I think that's a 9 that can come out of both of those. So this is 9 times 5. This is 9 times 2. And I can reduce that to simply 5 over 2. Now, if you don't know how to see that quickly, just take all the prime factors out, right? It would be 3 times 3 times 5 and 3 times 3 times 2, and just cancel out the 3's. But I could see that those 9's were going to come out pretty easily. All right, ratios involving decimals. How do you handle those? We will work often with ratios of decimals, especially when we have ratios involving money. In these cases, we can eliminate the decimals. So if we wanted to make a ratio with a decimal, we need to get rid of the decimals actually to get to a whole number. And how do we do that? By using the equivalent fraction property to convert the ratio to a fraction with whole numbers in the numerator and denominator. So consider this right here. How do we get this to go to a ratio? So right now we're going to rewrite it first of all so that it's represented as a fraction. Remember, 0.05, and we notice we have decimals, but we need whole numbers to properly represent this as a ratio. So in order to do that, I'm going to multiply by a factor of 10. Now I'm going to take those short somewhat longer route so I can show you something that happens. I'm going to multiply by 10. 10, and when I do that, this moves this decimal one place to 8, and this moves the decimal one place here to 0.5. There we go. Now, am I done? Well, we needed the fraction to be whole numbers. While the numerator is a whole number, the denominator is not. So I need to do that again. I need to multiply by 10 on the top and bottom in order to get this to be 80 over, because that moved from here to here, making there's a 0 there, and this moved from here to here, making that 5. So this is 80 over 5. That's what I was looking for. Now, that was a slightly longer way because I could have just took the decimal that was the longest and multiplied by 100 to start out with. But I want you to see what was going to happen if we didn't do that. And that it's okay. You just multiply by 10 enough times until all the numerator and denominator is at whole numbers. Now we want to simplify this, and I'm sure this is going to divide evenly, so I can just actually divide this one. And I know that because factors of 5 end in 0 or 5. So this is going to be, nope, not, that's going to be 1 and 3, and that's 6. So this is going to be 16 over 1. And you would have seen that by simply dividing, dividing this by 5 and dividing this by 5. So this is my ratio. Now, it's tempting for me to write this as 16, right? But again, we're representing a ratio, so we need to make sure we're saying 16 for every 1. And I was going to get some context to it, but we don't have any. But this is actually common if you're doing an exchange with money. Like you go to a different country and you're exchanging a dollar from the U.S. to a different country. It may be a 1 to 16 ratio, which means for every one of your dollars, they give you 16 units of their currency. So this is when a ratio becomes important. You're dealing with the I guess that's probably a rate. You got different units, but that's pretty close. All right, you don't need to write it every step. As long as the most important thing you need to do is make sure you multiply by the same number on top and bottom, so that you move the decimal the same number of places as you saw I did. I just make sure I multiply the top and bottom by the same thing. All right, let's try these decimals and get them to whole numbers. So I got 4.8 divided by 11.2. This time I'm not going to waste your time showing you each step. And actually I don't have to, because if I just move this decimal 1 and this decimal 1, they'll both be whole numbers. In order to do that, I have to multiply by, say it? Yes, 10. So that gives me 48 over 112. I'm almost done because I've got rid of the decimal, but they need to be what? Simplified. Now I can immediately see what factor is the greatest for these, so I'm just going to start pulling out the prime factors, or as many factors I see common. I know they can divide by 4, so I'm going to start with that one. I'm going to start with 4 and 12. Well, 12 is 4 times 3, so I'll break that down a little bit. And so this also is a 4. What is it, 112? I know it's a 4 because the last 2 digits are divisible by 12. It's a multiple of 12. That's a rule for finding out if it's divisible by 4 or not. So, but let's check what that actually equals. 2, 8, 3, 2, 8. So that's 28. So I know that's a 7 times 4. 7 times 4 gives me 28. So 4 times 7 times 4 gives me 112. So these are my factors for the top and bottom, and I can already see which ones can cross out, right? 4 and 4 can go. These 4 can go, leave me with 3 and 7. So my ratio for this one will be 3 over 7. All right, let me erase and get a little bit more room from that one. And we're going to choose a different color, hot pink. All right, now we're going to do this one here, 2.7 for 0.54. What's the ratio? What's the increase? Maybe you had a business and you went from 2.7 to 5.4. And you want to know, is it getting so many times larger, smaller? What's going on here? So first we're going to do is get this decimals out the way. I notice my longest decimal is at the bottom. I need to multiply by 100 to get this decimal to move twice. So I'm going to multiply by 100 on the top as well. Well, doing so gives me 270, because my decimal is now here, and there's a 0 that goes there. And down here gives me 54. When I reduce this even further, I can't quickly see what the greatest factors are. So I'm going to start pulling out my primes. And I know 27 times 10 gives me 270. And I can divide that 27 to 3 times 9. And that 10 into 5 times 2. That's pretty good. Now, I could have broken this 9 down further, but I can see that 9 is going to come out right here with 9 times 6. So I'm going to go ahead and put my 3 times 2 for 6, because I can see a 3 and 2 up there, and my 9 to give me a 54. And that lets me see, so let me make sure that I do that right. So 6 times 9 is 54. Yeah, 3 times 2 is 6. So these will cross out. These 9s will cross out, and these, oh, that's so beautiful. So now I'm just left with a 5 over, what, 0? Oh, absolutely, not 0, but 1. Because all these dividing out like this gives us 1. So now I know that's a ratio of 5 to 1. What that's saying is that 0.54, if you multiply that by 5, it's going to give you 2.7. Or in other words, 2.7 is 5 times bigger than 0.54. So this little piece right here helps us to understand this information a lot easier, and to see how much the difference is as a multiple. Like this going this many times bigger. And this is getting smaller, obviously, 4.8 to 11. 4.8 is smaller than 11.7. All right, what's the ratio of this guy? What about a mixed number? How do you handle that? Well, we're going to just do the same idea. We're going to write them as a fraction. So first of all, let's go ahead and write what we're looking at. 2 over 2/3. But we need to get these into improper fractions, so I'm going to make those improper fractions. 1 times 4 is 4, plus 1 is 5 over 4. And 2 times 3 is 6, plus 2 is 8 over 3. And now what we're looking at, we need to simplify this some more because it's not simplified. What we're looking at, if you think about it, is 5/4 divided by 8/3. Well, what does that equal to? Well, that's the same thing as saying 5/4 multiply or times 3/8, because that's how we divide fractions. And when we divide this, we get 5 times 3 is 24. And what did I say? 24. 5 times 3 is 15. But I don't want to actually multiply these out yet, because I'm going to see if I can cancel out anything. So I'm going to just write it out like this, and I'm going to write 4 times 8 as, can I cancel? I don't think I can cancel anything out there. So that may stay the same. So nope, I think it's just going to be the same. So I'm going to just write 15 times 15 over 32. I don't think these have any common factors. Let me check. 32 has 8, 4, 3. It doesn't have a 3 and 5. So just like that. So my my ratio is going to be 15 to 32. That's pretty sweet, right? Because we started with this, and now we hear it looks a lot more clean and simple to see what the relationship is between these numbers. Like we can see that this first one right here, 1 1/4, is about half of this one, because 15 is about half of 32, and it helps us make sense of it a lot better. All right, Hector's total cholesterol is 249. His HDL cholesterol is 39. Find the ratio between his total cholesterol and his HDL. So assuming that the ratio is less than 5 to 1 is considered good. What would you suggest of Hector? So find the ratio and assume that 5 to 1 ratio, less than 5 to 1 ratio is good. So if it's higher than 5 to 1, 6 to 1, 7 to 1, or whatever, that's not good. Now, understanding ratios, what you could do is simply multiply 39 times 5 to see what the total should be to fit in this parameter. And if I did that, 39 times 5, 15, that's 195. So he'll actually need to be at 195 to have a 1 to 5 ratio. And I can see that his total is going to be 249. I can already tell you that level part B, he's not doing too good, because he's at 249 when he should be at 195, which is a 1 to 5 ratio. So he's probably at 5 point or 6, or 1 to 5 point something, or 1 to 6 something. So we'll look at that and see what that looks like. Find the ratio. Well, we're just going to say, we'll say find the ratio of his total cholesterol to HDL. So this is total compared to his HDL. And notice that I'm writing it this way because I want to keep it in that order. I can't just start mixing these up because this is total compared to HDL amounts. So we want to be true to how they're setting it up. Your total is 249 divided by our 39. So we want to divide this out as much as we can, find out what common factors these guys have. And I'm going to say, let's see if it's divisible by 3. 9, 10, 11, 12, 13, 14, 15. So I can see that 3 would divide up both of these. Let's see, 3. I'm trying to think of anything bigger before I really get into this. Let's take out a 3 then. So let's divide both of these by 3. I already know that 39 divided by 3 is 13. And I'm going to do 249 divided by 3. Gives me an 8 and a 3 right here. So this is 83. So that's 83. Is there anything in 83? 8, 9, 10, 11? Nope. I can't take out. No. There's no. 13 is a prime number. So I know that it can't divide anything else out of 83 because it's only 13 and 1 for factors of 13. So this is my ratio. Now the question is this more than 5 to 1? Well, we already know the answer, but we can check it by actually doing the math. We're going to do 83 divided by 13 to see if the number we get is bigger than 5 or less than 5. So 13 goes into 83. I'm going to start with 6. 8, 1, 7. Yep. So that's 6. 78, and I got 5 left over. Decimal here, or actually don't need a decimal, need a decimal here. Assuming the ratio is, would you suggest, Hector? No, we can already say no to this answer just with this piece here. We don't actually need any more because we know that now there's a 6 to 1 ratio, which means that 13 times 6, he's at least 1 to 6. Here, at least it's going to be bigger because we have a decimal that keeps going. But we know that this is going to be at least 6 something over 1 because we can see that 13 times 6 is giving us a bigger number. So what would you suggest to Hector? I would suggest Hector to change his diet and start exercising because he's not doing too good. So that's how I would answer that question. Or probably not. I would show the math to show that it's greater than 1 to 5. All right, let's move on to discussing ratios of two measurements in different units. So we talked about ratios of the same units. What if we had different units? So what if we had different units? So find a ratio of two measurements. We must make sure the quantities have been measured with the same unit. If the measurements are not the same units, we convert them to the same units. We know that to simplify a fraction, we divide out common factors. Similarly, in the ratio of measurements, we divide out the common unit. Okay, actually, we're still using the common unit. We haven't got to rate yet. We're still at ratios. So we want to keep the units the same. So here's an example. The Americans with Disabilities Act guidelines for wheelchair ramps require a maximum vertical rise of 1 inch for every 1 foot. What's the ratio? Well, the ratio, we need the measurements, inches to every foot. We need this inch and this foot to have the same units. So right now, we can't pull a ratio from that. So we need to convert both in inches or both in feet, which is going to be easier. Well, it's always easier to use the smaller, the units that are in smaller increments. In this case, it's inches. So I'm going to keep my 1 inch, and I'm going to translate 1 foot into inches. And we know that 1 foot is equal to 12 inches. Now I have a ratio of 1 to 12. So now that makes sense as a nice, beautiful ratio. There's a 1 to 12 relationship in order for this ramp to meet their requirements. We don't want to say 1 to 1 because that's deceiving. We're not 1 foot to 1 foot, 1 inch to 1 inch. No. 1 to 12 is what we're looking for. Everything we just mentioned. All right, find the ratio of the first length to the second length. 32 inches for 1 foot. So we got 32 inches for every 1 foot. And again, I want everything in the same units. So instead of feet, I'm going to put this as inches. I'm going to convert that into 12 inches. And that's how I want my ratio to look, almost. What am I missing? I need to simplify it. Great. So what can we take out of both of these? I know 12 has a 4 and a 3, and this one has a 4 as well. So I can do 4, and do I have anything bigger? Yeah, I think 4 and 8, and 4 times 3. So that tells me that these 4's go away, and I'm left with 8 over 3. So 8 to 3 ratio. If you're going to use 32 inches to a foot, there's an 8 to 3 ratio. And let's do the ratio of this one. And I will pause it on these guys so that you can get your practice in, because I'm practicing quite a bit. But you got to pause it and be working these before I do them. So what would be the ratio here? 1 foot to 54 inches. Well, again, we want them all in the same unit. So I'm going to change everything into inches. And we're going to keep 54 inches. And we're going to change this 1 foot to 12 inches. Now, tired of using blue, so let's simplify this by taking out the biggest. Can I do 4? I think, no. 4, 3, I can do a 3. So I know a 3 can come out of that. 3 times 4 is 12. And I could take a 3 out of 54. What is 3 divided by 40? 54 divided by 3 is 2 for 18. So that gives me 3 times, I can still take something out of here, I see. So the 3's go away. Now I'm left with the 4 over 18, and those are both even. So 4 and 18 are both even, so I know we can do 2 times 2, and 18 can be 2 times 9. Crossing out my 2's, I'm left with 2 to 9. So there's a 2 to 9 ratio from 1 foot to 54 inches. All right, so write a rate as a fraction. A rate compares two quantities of different units. A rate is usually written as a fraction. So now we're talking about, what if the units are different? When are we going to see different units? Well, you'll see it in money, right? So you're working for $9 an hour. That means you're comparing dollars for every hour. Those are two different units. Or 120 miles for every 2 hours, words per minute, or like we talked about, money per ounce. When writing a fraction as a rate, we put the first given amount with its units in the numerator, dollars per, and then the denominator, the second unit, hour. So the units remain in the numerator and the denominator, and we make sure they're simplified. So let's look at some problems. That's going to help us work through those to make sure we got it. So let's look at first this one. Bob drove his car 525 miles in 9 hours. Write this as a fraction. Okay, it's pretty simple. 525 miles in 9 hours. Now, they're not asking us to do anything else but write as a fraction, and that's how it will look. So it looked like this. Now, I'm not done here because it says simplify. So I'm going to divide by 3 on both the top and bottom, and it gives me 175 miles for every 3 hours. And now I can say, so 525 miles an hour is the same thing as this rate of 175 miles in 3 hours. What about unit rate? What is that? Unit rate is when you have a denominator of 1. This is really important, especially when you're dealing with cost and trying to compare prices. So unit rates are very common in our lives. For example, we say that we're driving at a speed of 68 miles per hour. When we say that, we're really saying that we're driving 68 miles in 1 hour. So we'll write this as 68 miles per hour. So I remember someone had a difficult time trying to figure out how far will we go if we're driving 68 miles per hour in an hour. Well, you'll go 68 miles because that's the rate that you're moving currently. So another example is if you're working, right, and you're making $12.50 an hour. 12.50 per 1 hour. So we understand that pretty well. If you're reading this, you've probably worked or at least understand that concept. 12.50 per 1 hour. To convert a rate to a unit rate is really simple. We take our numerator and we divide it by the denominator. This gives us a denominator of 1, and that's going to give us our unit rate. Anita was paid $384 last week for working 32 hours. What's her hourly pay rate? How much is she making per hour? So she comes home and says, I made $384 and I worked 32 hours. And you say, wow, how much they're paying you per hour? She says, I'm not telling you. And you say, it's okay, because I actually know how to figure it out. You might not tell her that, but you know how to figure that out because we can just divide these two and know what this is going to give us. So let me divide this out. 384 divided by 32. So let's find out. 32 goes to 38 once. That leaves me 32. Subtract this, it gives me 6. 32 goes into 64 twice. So that gives me 0. So now I know that this person's making, so this was 384. So, but she's making $12 per 1 hour. So this is her rate, and notice that the units are different, but now we know her unit rate, how much she's making per every 1 hour, which is a very powerful tool, by the way, because now you can make a prediction and projection down the road and say, wow, if she worked 40 hours or 100 hours, I can go ahead and tally what you're likely to be making, given that no money's added or taken away. Sven drives his car 455 miles using 14 gallons of gas. How many miles per gallon does his gas get? That's a very important question. If you want to compare your miles to gallons and see if you get a very efficient car. So 14 gallons. We're going to divide those two, right? So we want to divide 455 divided by 14. I'm going to change colors. 14 goes into 45. Let's see, 28. I'm going to guess 3 times. Let's see if that's the biggest. 2, 1. Yeah, 42. So there's a 3 here. And that's 42. I'll make sure I did that right. 12, 2, 1. Yep. So there's a 3. Bring down my 5. 14 goes into 35 twice. 2 times 14 is 28, and that leaves me with 7. Got a decimal here, bring down that 0. 14 goes into 70. Let's guess about 5 times. 2. That was actually perfect, so fantastic. So we've learned that there's going to be 32.5 miles per 1 gallon. Very powerful information, unit rate. So now again, you can project how far you're going to go. So I should say miles here. How far you're going to go with so much gas in your car. You're like, well, if we got 2 gallons, we could travel this far. Why? Because we have the unit rate, which is going to allow us to have a discussion about things that can happen further down the road. No pun intended. Sometimes we can buy common households in bulk where several items are packaged together, sold for one price. To compare the price of different size packages, we need to find the unit price. To find the unit price, divide the total price by the number of items, like we've been doing. So let's compare a couple of things. Let's, for instance, if we had this, what's the unit price? We got a pack of bottles, and we want to know how much each bottle is going to be. So in order to do that, we're going to take the whole pack, cost $3.99, divided by 24, and goes to the once. That'll give me 5, 1, bring down our 9. 24 goes into 159. 1, 2, 3, 4, 5, 6. I'm guessing about 6 times. Let's multiply it out. 6 times 2 is 12, 144. And 2 times 24 is, or 12 times 24. No. 140. What did I put? Why did I put 2 there? This is supposed to be 6. So 6 times 24 is 144. And now I got 5, 1. And we're going to bring down our 0. 24 goes into 150. Still 6 times, because it's still going to be about 144. So 6 times this is 1. And we really don't have to go any further because we're talking about unit price. And price for our money system doesn't go past the hundreds place. And you can see already our hundreds place is here at 6. So we can go ahead and round and say it's going to be approximately 17 cents per one bottle. So it's about 17 cents a bottle, because we can't, it's no point in going all the way down here because we don't have money that goes that far. This is a penny and we don't have something smaller than a penny. So we're going to round at the penny and say, because that was a decimal here, and simply say that this is about 17 cents per bottle. And we can compare that to other packages with different prices. Now our last one, we'll actually do a comparison here and figure out which one is the better price. Paul is shopping for laundry detergent at the grocery store. The liquid detergent is priced for $14.99 for 64 loads of laundry, and the same brand of powder detergent is priced $15.99 for 80 loads. Which is the better buy? So let's do it. There's 2 problems. So let me see if I can get that set up. We got 14. We'll call this one the liquid over here. So this is my liquid, and this is the powder. Which one do you use? So liquid is going to be $14.99 for 64 loads, while the powder is going to be $15.99 for 80 loads. All right, let's do the math. Now, of course, you can use a calculator with these and just divide them, and that's really the important part, is you know how to do it. But I want to go ahead and work it, because some of us may not have the luxury of having a calculator in here. You may have a teacher who's asking you to work out each piece. 64 goes into, can't do 14, 149 twice, because that'll be 128. That'll leave me with 1, 2, bring down my 9. That will probably go in there 3 times. Let's see, 64 times 3, 2, 1, 18, 19. Yep. So that'll be 3 times. 3 times this is 192. These move 7, 11, 27. I could bring down a 0, and this is probably as far as I'm going to go, because again, we're dealing with money and we're already at the hundreds place. So I just need this last number to round it either up or down. And so 64 goes into 270. I'm going to guess, and notice I do my extra scratch work on the side, so as to keep it separate from my actual linear work here that I'm kind of going straight down. 6, 1, 4 times 6 is 24, plus 1 was 25, so yep, it'll go in there 4 times. And that's, I'm not going to go any further because this is what I needed. I needed to know that it's going to be about, let's say about 23 cents, because I'm going to round down as I look here to the 4. I'm going to round down to 23 cents per load. And on this one, I'm going to do the same thing. $15.99 divided by, oh, I already did that. So let's actually set it up. 80 goes into 159. My goodness, it could have been twice. Oh, that's going to be a big. All right, so that's going to be, so that's 80. So this is going to be 79. My. Yep, 79. 80 goes into 799. Wow. 9 times, because I know that 80 times 10 would have given me 800. So I know that's 9 times, and that's going to give 9 times 80 is 720. I need one more decimal to round it properly. Actually, I don't, do I? Look at this. I have 19 cents here already. So this is approximately, I can say this is approximately 19 cents, just to see which one's better. Now, I could figure out what this is. It could go up to 20, but it wouldn't matter because we already at 23. So this, we want the cheaper one, right? So this is going to be our better deal. The powder version is going to be our better deal. I know that took a little bit of work, but there we go. All right, did we answer our questions? What's the rate and ratio? Rate is we have the same units. Ratio, I'm sorry, rate we have different units. Ratio we have the same units. How do we write rate and ratio as a fraction? We talked about that. We just talked about unit rate and how you handle them in these real world problems. So thanks guys for tuning in. My name is Brandon Clayton, and I will see you next lesson.